Hello students, welcome to CMS online classes. This video is for class 7 and today we will discuss about chapter 5 acids, bases and salts. Okay. So today we will discuss about the topics. Here are the topics and student this topic will be new for you, so just understand properly. Is it clear? So these are the topics you can see. We will discuss what are acids actually. In our day-to-day life also we use many types of acids. So we will know the definition of acids. Next, properties of acids, what an acid can do. Okay. Next, what are bases? Again same in our day-to-day life how we are using the bases, the uses of bases, the properties of bases. After that we will see about the neutralization reaction. When acid and bases they mix together, that process is called neutralization. That also we will see. And the last one, that is the how are salts formed. That we will see. Okay. Next, so first we will discuss about the acids. So acids are actually generally sour in taste, khatta. Okay, can you see student this diagram over here? Can you see? You can see some diagrams like this is a vinegar, this is the aspirin tablets. Okay, this is the lemon and this is spinach. Can you just see students? Okay, so these are actually some sources of acids. And what is common in that, students? Like if I will say students, in vinegar, amla, then lemon, then also we are having the acids in the curd. So what is common in that? What is the taste of these all, whatever food I told students, like the citrus food, amla, what is the taste? It is sour in taste, isn't it? So acids are generally sour in taste. They are also derived from a Latin word that's called acer, which means also sour. That's why they are called as the acids. Okay, so the substances which are sour in taste and have acidic ingredients and their solutions are acidic, those substances are called as acids. Is it clear, students? So the substances which are sour in taste and have acidic ingredients in them, and if you will just make solutions of acids also, they also produce the solutions that is acidic. Okay. So students, here you can see the sources of acids. So these all are actually the natural acids. Okay, I will start from this lemon. So lemon is having the citric acid, and students please note down which acids are present in which type of food. It is very important. The name of the acid you have to remember. So in lemon the citric acid is present, and as you know that citric acid is a source of vitamin C, isn't it? To just avoid to overcome the scurvy. That's a deficiency disease for vitamin C. That is that can be overcome by taking the citrus food, and that is the acid present in the lemon, then the orange, that is the citric acid. Next, in tomatoes also we are having one acid that is called oxalic acids. Next, in grapes and in tamarind, imli, in that we are having the tartaric acids. Okay. Next, in milk, in curd we are having lactic acids. And as you know that the bacteria also, we know about the bacteria which convert the milk into curd, that is the lactobacillus. So from this lactic acid only, because they convert the lactic acid. Is it clear? So that is also known as the lactic acid, the acid present in the milk and curd. Next, when an ant bite, okay, in that place mostly we feel some inflammation, isn't it? And that inflammation is due to the formic acid, that is by the ant. In apple we are having the malic acid. And do you know, students, one thing, that malic acid are actually the waste of the plant. Okay, that's why they store the waste in the fruit, so that if the fruit will be plucked, then they will get rid of the waste also. So the malic acid is present in the apple. And as you know that the vinegar, and the vinegar is mostly used in the pickles. It's mostly it is used as a food preservatives, and that is the vinegar. If you will see your pickle bottles at your home also, if you will see the ingredients, you will definitely find the vinegar, because this vinegar is used as a food preservatives. Okay. Next, you will see, student, the types of acid, and first is that is the based on source, from which source they are derived. So as you can see, two types of acids are there. One is organic or natural, and the second one is mineral, inorganic or artificial. Is it clear? So I will just tell students what are organic acids. Acids obtained from natural sources. As you can see, citric acid, that is from what? Citric acid from the lemon, acetic acid, that is the vinegar, and the lactic acid, that is in the curd. And mineral or inorganic or artificial acids, what are they? The acids, they are synthetically produced in the laboratory, and they are very dangerous also, students, like the hydrochloric acid, the sulfuric acid, nitric acid. So these are the types of acids based on source. One more type is also there, student, that is based on strength. They are the strong acids and the weak acids. So strong acids are actually corrosive in nature. If you will put some acids on the floor, the strong acids mostly, they can corrode the floor. Have you heard about, students, the acid rain and the marble cancer of Taj Mahal? That means the marble or the shining of the Taj Mahal is degrading day by day due to acid rains. So that acid rain contains some of the nitrogen acids or nitrogen oxides and some sulfuric acids. Nitric acid and sulfuric acids are actually their strong acids. Okay, and also they cause burns on skin. I think, students, you must have heard about the movie Chapak. That's actually a real story, isn't it? The acid attack victim. So actually what happens when they throw the acid to the face of the girl or the victim, actually what happens at that time, it causes burns on skin, and they are actually using the strong acids, because weak acids, they don't corrode or they don't cause any burns on skin. So examples of strong acids are sulfuric acid and hydrochloric acid. And weak acids are, they're mild in nature, they're very weak and don't cause burns on skin. Suppose if it would be burning sensation is there, then we cannot eat the curd, or we cannot just squeeze one lemon, isn't it? When we squeeze a lemon, we don't feel any burning sensation on our hands. So weak acids, they don't cause burns on skin. So examples are oxalic acid, acetic acid, citric acid, all these are weak acids. And also, students, one more division, that is, it is based on the amount of water dissolved in it. They are concentrated acids and diluted acids. Okay, means which amount of, if the water is, the acid amount is more and the water amount is less, then it is called concentrated. And diluted means if the water amount is more than the acid, that is called the diluted acids. Okay, next we will see, students, properties of acids. First, the sour to taste, we know already. Next, they are soluble in water. All type of acids, they are soluble in water. And also they conduct electricity. So electricity also can pass through these acids. Next, corrosive in nature, and also they cause skin burns. And the last one is the can be stored in plastic. But here, students, I will tell, not all the acids are corrosive. Only mostly the strong acids are corrosive in nature. And the last one is can be stored in plastic or glass bottles. But they should not be stored in a metal container. Why? Because acids react with the metals. Isn't it? So in the laboratory also, you can see the acids are kept either in glass bottles or plastic bottles, never in a metal container. Okay? Next, what are the bases? So can you see, students, these are some bases like the baking soda that we use in our food. Okay, the sanitizer, the hand wash, then the drain cleaner, then the surf we use to wash our clothes, isn't it? So these are some bases that we use in our day-to-day life. So bases are generally bitter in taste. Like the acids are sour in taste, the bases are bitter in taste. The substances which are bitter to taste, the ingredients are basic, and their solution are also basic in nature. They are called the bases. So the solution, when the bases are mixed and they are made the solutions are basic in nature. Next, the types of bases, that is strong bases and weak bases. Examples you can see, students, sodium hydroxide, potassium hydroxide, and in weak bases, magnesium hydroxide, ammonium hydroxide. Okay. Next, properties of bases. So when mostly we just use our soap or detergent, students, do you feel some slippery things? Yes. So properties of bases, actually they are slippery to touch. Next, they are bitter to taste, and they also conduct electricity. So here one similarity, students, in between acids and bases, that is they both conduct the electricity. Okay, and few bases are soluble in water and they are called alkalis. So not all the bases are soluble in water unlike the acids, but all the acids are soluble in water. So few bases are not also they are not soluble in water. Okay. Next one information student, this table you remember. Okay, this comes and actually in the short question. Okay, like what are the acid, name of the acid and the sources. Like the acetic acid is found in vinegar. The formic acid is found in the ant sting. The citric acid, all types of citrus food. Next, the lactic acid is present in the curd. Next, oxalic acid is present in the spinach. Ascorbic acid is present in the amla or the citrus food. Next, tartaric acid is present in the tamarind, grapes and unripe mangoes. So all these are the acids. Next, you can see students, and they are also the natural acids. And you can see students some bases also, like the calcium hydroxide, it is the lime water. Yes, and students, lime water is not the lemon water that lemonade we prepare at home. Lime water is different. Okay, when the means lime is just mixed with the water, simply we call as chuno pani. Isn't it? Lime water, that is calcium hydroxide actually. Next, the ammonium hydroxide, that is in the window cleaner. Next, the sodium hydroxide or potassium hydroxide that we use in our soap. Any type of soap you can take. That is the ingredients must be sodium hydroxide and potassium hydroxide. Next, magnesium hydroxide, that is milk of magnesia. And milk of magnesia, mostly it is taken for the as an antacid. When a person is suffering from acidic condition, okay, the burning sensation in the stomach or in the esophagus, they take milk of magnesia to neutralize the reaction. Am I clear? Next topic is students, indicators. So students, you see the table. So we are having three categories. One is natural indicators, second is synthetic indicators, and third one is the olfactory indicators. Am I clear, students? Is it visible clearly? So first we will discuss about the natural indicators like the litmus paper, and that is derived from one plant. Okay, that I will show in the next slide. So litmus, then the red cabbage, then the flower of hydrangea plant, and the turmeric. So as you can see, student, the color, how the color changes in acidic solution and basic solution. Litmus, red litmus paper, they change the color into blue when they are put in the basic solution. So you can see the table carefully, students. Yes, and you have to remember also, this table you have to remember. So as you can see here, I have given some examples. So these are the natural indicators from lichens. Actually, the red and litmus papers are, litmus paper also it comes in the solution form, but most widely used is the litmus paper. Okay, next the turmeric, next the plant, hydrangea plant, and the red cabbage. So as you can see, students, China rose. China rose is also one type of, as you can see, student, the China rose is also one type of natural indicators. Okay, so as the color you can see, the indicator that is light pinkish in color, but when it is put in the acid it becomes red, and when it is put in the base it turns to green color. So this is also one indicator. Next is the turmeric. Okay, the next you can see, student, the turmeric, we have taken one means lemon water, and we have taken the soap solution, and when it is put, the turmeric doesn't change the color in the acidic one, but in the base you can see the red coloration, isn't it? So that's why when we are having a stain on your cloths of dal or any yellow color, then when we put the soap it becomes red, isn't it? So that is the reaction actually. Next is the red cabbage. So actually the color is this, but when it is kept in the baking soda as a base, so it is changing into light greenish color, and in vinegar it becomes pink. Is it clear, students? So this is about the natural indicators. Next is our neutralization. So you can see, students, acid plus base, it gives rise to the, as you can see the figure, salt plus water, isn't it? That means what is neutralization? The reaction between an acid and a base, and it produces a salt and water always. So I can give example of, students, our common salt, that is the NaCl. So here is the equation, students, and this equation is very important. You have to remember some equations for neutralization reaction. So here you can see HCl is the acid and NaOH is the base. So here, students, we have taken both are the strong acids and strong base. HCl is strong acid and NaOH is strong base. So when they combine together, they form H2O and NaCl. NaCl is the salt and H2O is the water. Is it clear, students? So this is about the neutralization reaction. Now I will show you, students, the pH. Actually, what is pH? You can say the power of hydrogen ion. So what is the hydrogen ion present in one substance that is denoted as the pH? And the acidic and basic, the pH range is 0 to 14. As you can see in that scale also, 0 to 14. The 7 is the neutral one in the middle. So 7 is the middle one, and the means pH of water, that is the 7. That means neutral. Is it clear, students? So when it is going up like 7, 6, 5, 4, that means that is acidic. As you can see the arrow also. So just above 7, less than 7 will be acidic, more than 7 up to 14 will be basic. So here we are, whatever we use in our day-to-day life, already I have given. So you see, 7 is neutral, human blood is slightly alkali or it is slightly basic, that is 7.5. Next the baking soda, that is 8.5. The detergent we use, that is pH 10, and the bleach, that is 12.5. Okay, like that, if you will go less than 7, then the raindrop, that is having the 5.5, it is slightly acidic. Okay, wine is 4. Next, the lemon juice is having P. And do you know, students, in our stomach also one acid is produced? Yes, HCl. But why don't we feel the corrosion in our stomach? Because we are having the what? The mucus in our stomach lining. That's why we don't feel the acid. When the acid is also, and it is liberated all the time, but we don't feel any pain, isn't it? But sometimes what happens when our stomach is empty, we feel some like inflammation in our esophagus or stomach lining. At that time, we take the milk of magnesia, and that is a base. So neutralize the reaction. Is it clear? So these are the homework, students. You note it down. What are indicators? Next, differentiate between acids and bases. Define neutralization. Why is milk of magnesia advisable when a person suffers from acid? And write the properties of acids and bases. So these are the homework for this chapter. And also you do your exercise question answer, students, in your copy. So we have completed this chapter. Next class, again we will be discussing about the next chapter. Is it clear? Thank you.